Good morning, my YouTube viewers. Crystal here. I decided to make a second video for you because if you watched my earlier video, you'll know that I was talking about the iterative imputer, and I decided that I was going to go ahead and check out the iterative imputer and see if it improved my score with the dengue fever competition question with driven data. And I got some very interesting results, and I wanted to share that with you. I'd like to say I'm sorry about the quality of the audio on my computer. For some reason, even though I have it set up only where it will record my voice, it still is picking up a lot of noise, so sorry about that. I'm going to be getting a new computer after my birthday that's going to be a Microsoft-based computer, and hopefully a lot of these problems will be resolved. Even though I do love my Chromebook, I have to say I love it, but I need to get a Microsoft computer as well. So without further ado, what we'll do is we'll go ahead and go over a competition question, and I'll tell you what I did to solve it. I will say that when I submitted it to the Driven Data Solution Checker, I got a 26.59, which was an improvement of 3 points since I started working on this competition question. The last competition question I had a 27.5, and what I did with that was I did some feature selection. But the thing about these competition questions is you need to keep on working on them to try to move up on the leaderboard. That's the name of the game, is to move up the leaderboard. So I'm in the leaderboard. So the first thing we'll do is we'll talk about our problem statement. Dengue fever is a mosquito-borne disease that occurs in tropical and subtropical parts of the world. In mild cases, symptoms are similar to the flu, fever, rash, and muscle and joint pain. In severe cases, dengue fever can cause severe bleeding, low blood pressure, and even death. Because it is carried by mosquitoes, the transmission dynamics of dengue are related to climate variables such as temperature and precipitation. Although the relationship to climate is complex, a growing number of scientists argue that climate change is likely to produce distribution shifts that will have significant public health implications worldwide. In recent years, dengue fever has been spreading. Historically, the disease has been most prevalent in Southeast Asia and the Pacific Islands. These days, many of the nearly 500 million cases per year are occurring in Latin America. Using environmental data collected by various U.S. federal government agencies, from the Centers for Disease Control and Prevention to the National Oceanic and Atmospheric Administration and the U.S. Department of Commerce, can you predict the number of dengue fever cases reported each week in San Juan, Puerto Rico, and Iquitos, Peru? Problem statement. We have to predict the number of cases in San Juan, Puerto Rico, and Iquitos, Peru. Really, this sort of looks like a time series analysis to me, but in the data set, the times and the cities back each other up, and I'm not sure exactly how to deal with that. So I decided to go ahead and use traditional machine learning methods, because you can use AdaBoost on time series. I just found that out yesterday. I did use AdaBoost on it, but you can use it on time series. If you look at one of my blog posts, I discuss a paper that I looked at where they covered 111 data sets or time series, and they gave their results, but it was very highly technical, and I was in a hurry, because I've got to get these videos out. I've got to get these blog posts out. So I don't really have time to, scour through it. But apparently it just said that if you adjust your tuning, your parameters, then the results will be better. But of course, we already know that by just using traditional machine learning techniques. So the first thing that we have to do is we have to load our libraries, and we use the libraries that are going to be most common. And the thing we have to do is we have to load our data sets. So these data sets are in my GitHub account. You're more than welcome to use them if you like, but if you want to download them from data-driven, they're in data-driven as well. You've got your train file. You can see that your train file has got lots of information in it. You've got your test file. Your test file is the same format as a train file, with the exception that it doesn't have as many rows. You've got your labels. Your labels tells you the year, the week of year, and the total cases. And you've got your sample and what the data wants to see when you submit your predictions to them. So the first thing we have to do is we have to merge the train labels with the train file, because the train labels tell you how many cases of dengue fever you got, and the cases of dengue fever are actually your dependent variable or your target. And so the train is merged with labels on city here and week here, and it's merged to the left. So now you've got your train info. It tells you all about this train file, and you've got mostly numeric columns, but a few objects. So then what I've done is I've given you a little graphic chart of how many cases of dengue fever that you have. And so that's just a graphical representation of the cases. And here is a numeric representation of the cases that again tells you how many cases of the dengue fever that you have. Now what we're going to do is we're going to check for any null values. And as you can see, there's quite a few null values that we have to impute. Okay, so now what we're going to do is we're going to ordinal encode the columns that were objects. So we're going to ordinal encode the city column, and we're going to ordinal encode the week start date column. So these are going to be ordinal encoded to make them numeric objects. So now what we're going to do is we're going to replace all the null values. And basically what I had to do is all of the values that were null, I had to replace that with NP-NaN. So all of these values have to say NP-NaN. So we did that on the train file and the test file, and we used a little function for C and train columns. Train C equals PD to numeric, train C errors equal bars. So that means everything that was a null value is now going to be NP-NaN. So now we have a graphical representation, and this graphical representation tells you how many are in one value and how many are in the other. We put it on a counter so you can see that we've got 936 in number 1 and 520 in 0. Now what we do is we define our x, y, and x test variables. So y equals train total cases values, x equals train drop, week start date, total cases, axis equals 1 values, x test equals test drop, week start date, axis equals 1 values. Now what we do is we take our training set and we split it for train and validation. So X train, X val, Y train, Y val equals train test split, X train test size equals 10%, random state equals 1, shuffle equals true. And now what we've done is we've come to the iterative imputer, which is a new function. It's a new function in sklearn, so it's still experimental. So imp equals iterative imputer, random state equals 1, X train equals imp dot fit transform X train, X val equals imp dot transform X val, X test equals imp dot transform X test. And what that does is you have to fit it on the X train, and then you have to transform it on X train, X val, X test. So now what we do is we standard scale all of the data, and that's also in the sklearn library, and that's done by similar to iterative imputer. Scalar equals standard scalar fit X train equals scalar transform X train, X val equals scalar transform X val, X test equals scalar transform X test. And then what we do is we check the values or check the shape of these columns that we have created, or the data frames that we have created. And now what we do is we define our model, and we used ADA boost regressor and gradient boosting regressor, and so we had like a 99.78% on the X train, Y train, and then we predicted on X val, and we had a 78.87% on our prediction for X val, and we had a 99.96% on our R2 score. So we put the prediction, and what we did is see the Y pred to see the values that were in there. Now what we do, we put the actual values and the predicted values in a data frame so you can compare the values. Now what we do is we predict on the test set, and we have our final result that we put in a data frame. And we convert the data frame to a CSV file, and when we've converted the data frame to a CSV file, it'll come up as a CSV file, and we submit that to Driven Data Solution Checker, and I got a 26.5962 when I submitted it, which is a 3-point increase of when I first started submitting them, and the best score is 10%. So I've got to go like 16 points. I've got to move up the leaderboard 16 points, but these are just my small efforts to move up the leaderboard, and I wanted to make a video and show them to you. And because I've got a Chromebook, I can't look at my program on GitHub, so I'm using a program called NB Viewer. But what I will do is I will leave you the link to my GitHub account, and you can go onto that GitHub account and follow along with me if you like. So if you like my videos, please like, subscribe, and share. If you like the work I do and want to support me, I have my email address to my PayPal account down below. I don't have enough subscribers to monetize, so I have to ask for donations. Thank you so much for watching my video, and I look forward to making more videos for you.